determine the existence or otherwise of the following limit. It is the limit as x approaches infinity of x squared plus x plus 1 over x minus 2. So something like this. You could sort of have a cursory glance and see if you can factorize the top, and then say x minus 2 was one of those factors. You might be able to turn it into a linear function with a hole in it. In this case, that top's not going to factorize. So then what you want to do is try to make use of these facts, which are the limit as x approaches infinity of something like 1 over x equals 0. Lim as x approaches infinity of 1 over x squared equals 0. This is 1 divided by a lot, 1 divided by a lot. And that's just going to happen for all of these powers as they go up and up and up. So what we do, we're looking to find the limit as x approaches infinity of x squared plus x plus 1 over x minus 2. So what we do, we take top and bottom and we divide them both by the highest power of x, which is the x squared. So what we do, we take the numerator and the denominator and we times them both by 1 over x squared. So we're timesing this whole thing by 1 over x squared over 1 over x squared, which this total thing has a value of 1, which is crucial because it doesn't actually change the value of the function that we're trying to find the limit of as it approaches infinity. So what we're going to do equals the lim as x approaches infinity of x squared over x squared. And I am going to show all the working. I think I'm showing it. I think you probably should most of the time, especially if you've been asked to show that a limit is this. You really shouldn't skip a lot of working. So this is x squared over x squared plus x over x squared plus 1 over x squared over x squared minus 2 over x squared. Okay, so just tidy that up a bit. So that equals the limit as x approaches infinity of, so this is 1 plus, this is 1 over x plus 1 over x squared was fine anyway, over 1 over x again minus 2 over x squared. So now we can make use of what we know. And by the way, you might be wondering about this 2 over x squared. Well, if you think about this is really just, if you pull the minus 2 out, it's minus 2 times the limit of as x approaches infinity of 1 over x squared. So that minus 2 is not going to change this thing being 0. That 1 over x squared bit is going to be so small that when you times it by minus 2, it's not going to make any difference. And it's a limit law anyway. You can pull a factor out, no problem at all. Right, so now we can just evaluate these individually. Remember, the sum of the limits is the limit of the sums, and the limit of the quotients is the quotient of the limits. So what we're going to do is just evaluate each limit individually. So whenever there's no letter involved, it's just the constant. So this is 1 equals 1 plus, we know that the limit as x approaches infinity of 1 over x is 0. The limit as x approaches infinity of 1 over x squared is 0 over, again, 1 over x, limit as x approaches infinity is 0. And this is definitely 0, minus 0. We've got 1 divided by 0. 1 divided by 0, so it does not exist. Limit as x approaches infinity of f of x dne.